All right, so at the end of the last class, we were talking about the relationship between classes. And in particular, we had looked at dependency, association, and aggregation. And now I'm going to talk about a relationship called composition. So composition is the form of aggregation. So it's a stronger form of aggregation, right? That's really annoying. All right. And remember that composition implies ownership, right? Whereas aggregation does not. Okay, so if an object X is composed of an object of type Y, that means X has a Y object, right? So that means in your class X, there's a reference to a Y. Okay, you get class X, right? And one of your fields has type Y. Right? And of course, you might have other fields in your class, right? But one of them for sure is of type Y. Furthermore, every X object owns its own Y object, right? So we need to ensure that our class X has exclusive ownership over that Y. Right? So that's the point of today's lecture, right? We're always going to try to ensure that that blue box is always true. Right? Now, what does it mean for that blue box to be true, right? So in order for X to have exclusive access to that Y, we can never release a reference to that Y. Right? So in our constructors, we're always going to make a new Y object. Right? Any method that returns Y returns a copy of Y. It doesn't return just Y directly. Right? We can't return Y directly because that gives somebody else a reference to Y. Any method that takes in a Y object and tries to store that Y object has to make a copy of that Y object and then store it in Y. Right? We can't just store a reference directly to someone else's Y because that means somebody else has a reference to that Y object. Right? Now notice every time you call a method involving the field Y, right? Any method that might change it or return it, right? You have to make a copy, right? So those new Y objects, those are called defensive copies, right? They're defensive because we want to make sure that nobody else gets a reference to that Y. Okay, so if you have a no argument constructor or default constructor, well, this isn't really composition. You have to do this no matter what. Right, so in your no argument constructor, you make a new Y. But we do that anyway, so that's not really anything new. Okay, now what about a constructor that takes in a Y object? Right, so here we've got a constructor. One of its inputs is a Y object, right? I can't just write this Y equals Y. Because if I do that, you're now sharing your internal reference, right? You're sharing that Y with somebody else. Right, so what you have to do is you have to the very first thing is you make a copy of that Y object. Right? You make a copy of the incoming Y. Right? Now, if there are some conditions on that Y object, right? So if your class has some invariant that involves Y, you then have to check, right? Or validate whether or not the incoming Y satisfies those conditions. Right? So now you validate the copy. Right? You don't validate the original Y. You validate the copy. Right, so I've got some mythical method called check Y here that does the validation for you. Right? Whatever check Y has to do. I don't know what it has to do because in general, right, it could be anything. So I've just got this made up method called check Y that does the validation. Only once you pass the validation can you go ahead and set this Y to be equal to the copy. Right? And now the class has insulated itself from whoever has a reference to that original Y. Right? Because that person does not have a reference to the copy, right? So that copy is, that's probably not going to help. I think it's coming through the, yeah. Thanks though. Okay, so that copy there, right? So when you make a copy of an object, assuming the object's not a collection of some kind, that's called a deep copy. Right? Now why do we need that? Because I need to ensure that every X object has exclusive access to its Y object, right? If you write this, right, that line of code, which is what you would probably write if I hadn't told you about composition, right, you no longer have a composition. You now have an aggregation, right? Because you've got somebody else has a reference to that y object, right? When you write this y equals y, you're saying this y and y, well, they're the same object, right? So now you've got a shared reference, which you have to avoid in composition, right? So in this case, there's now two, I guess, objects that have a reference to y, right? There's the object that called the constructor, and now there's the x object itself. If you're implementing a composition and you accidentally release a reference to your internal object, that's called a privacy leak. Right? So that's what's on the slide shown to you there is an example of a privacy leak. Right? Someone else has a reference to y. That means they can modify y. Okay, if you have a copy constructor, the same thing applies. Right? So you have a copy constructor that takes in another x object. Right? What does this constructor have to do? Well, it needs to set this dot y, right? So how does it set this dot y? It does not write this dot y equals other dot y, right? It makes a copy of the other object's y object, right, like that, assuming there's an accessor for get y, right? If there isn't, then you just write other dot y, right? Hopefully that y has a copy constructor, right? So this assumes that y has a copy constructor. But the Java language does not guarantee that every class has a copy constructor. Right? So if the class doesn't have a copy constructor, you normally have to do something else. Right? You have to find some other way to copy the object. For the most part, it's not terribly difficult to do, but it's possible that you run into a situation where there's no obvious way to copy the object, and then you have another problem. Right? So what happens if you write this dot y equals other dot y? Right? Then you're now sharing. Right? This object is now sharing its y object with the other x object. Right? So that's shared ownership, which is not composition. Right? If you use that copy constructor to make all of your x objects, what ends up happening is, right, every x object that's created ends up sharing its y object. Right? So in other words, if you make 10 objects with that copy constructor, there's only one y object kicking around. Right? They don't own their own y object. Right? That means if one of those x objects modifies its internal y object, all of the x objects end up with a modified y. Right, which is probably not what you want to do. Right? And again, that's a privacy leak. Right? Anytime you release a reference to your internal y object, that's called a privacy leak. Only when you're implementing composition. Right? If you're implementing an aggregation, then the privacy leak is intentional. So we don't call it a privacy leak. Right? It's just aggregation. Okay, so we've got this little projectile class or object. It has a copy constructor. Right? You want to copy another projectile. Right, so how do you do it? Do I have Eclipse open? I don't have Eclipse open, sorry. I'm just going to do it on the slide. Okay, so instead of writing this position, right, so don't do this, for example. Right, so don't set your position to be equal to the other object's position. Instead, make a copy of the other object's position, and then set your internal reference to the copy. Right? Similarly, for this velocity, don't write this velocity equals other velocity. Right? Instead, make a copy of the object, and then set your reference to be equal to the copy. Like that. Right? Now, notice the price that you pay when you implement a composition. Right? Every time you make a new object, you end up making copies of all the internal objects. Right? So right away, this particular object takes up, so using the, in the projectile class, every time you make a new object, you end up doubling the amount of memory you need to make the copy of the other object. Right? Because there's now a new point2 and a new vector2 object kicking around. Okay, if you have an accessor method that's supposed to return the internal y object, right? Don't return the internal y object directly, right? Make a copy, and then return the copy, right? Why do you have to do that? Again, right, because you always need to ensure that every x object has exclusive access to its internal y object, right? If you do that, right, you've just handed out a reference to your internal y object, right? Anybody who gets that reference can modify the y object, and now your object changes, right? So again, that's called a privacy leak. So if you've got a method called getPosition in the projectile class, right, and you've got a method called getVelocity in the projectile class, don't return this position and this velocity. Right? Instead, return a copy. Right? So return new point 2 in this position. Whoa. Right? And from the velocity, you return new vector 2, this velocity. Right? So you're always returning new objects. Right? And again, notice the price that you're paying in implementing a composition. Right? If someone wants the position of the projectile, you now have to make a new point and then return that new point object. Right? If they don't use the return value for anything, the garbage collector has to come along and get rid of that object right away. Well, it has to get rid of that object. Right? So now you're paying the price of creating new objects, which takes time. Right? It takes memory, and then it takes additional time to get rid of that object. Right? So when the garbage collector comes along and gets rid of the returned object, that takes some time too. Okay, if you have a mutator method that's supposed to set that y, right? So it's going to have a y reference as one of its parameters, right? Then the first thing you do is you make a copy of that incoming y object, right? So make a copy, validate the copy, right? And then set y to be equal to the copy, right? In this course, the order of the validation and the copying, you'll never see a problem if you flip the order. It's only when you write what's called a multi-threaded program that you might encounter a problem, right? Which is why I'm telling you to copy first, then validate, right? But in this course, you're never going to see an issue if you flip these two around, right? In other words, you'll never write a unit test that detects the error. Okay, so why is the copy required? Because if you write this y equals y, you're saying my y object is equal to, or is the same object as, the incoming y object, right? So now you've got a shared reference again. Again, that's called a privacy leak. Right? So here, if you want to set the position to the incoming point 2 object, you write this position equals new point 2 position, right? And you write this velocity equals new vector 2 velocity. Right? So you're always making these defensive copies. Okay, so what's the price of defensive copying, or what is the price of composition? Right? So the defensive copies are required when you use a composition. But the price of the defensive copying is the time and memory needed to create and garbage collect the defensive copies. Right? So that program that shows you the bouncing ball, right? If you change the implementation of the projectile class to use composition, right? Then you can actually calculate how many point 2 objects are being created every second. Right? So that ball moves every 25 milliseconds, right? Which means you're making 40 point 2 objects every time you move every second. Right? Because every time you move the ball, it returns the position of the ball, right? So it has to return a copy. So you end up making 40 of these things every second. Now that's just one ball, right? That's just one object, right? In a modern video game, there's literally millions, tens of millions, or hundreds of millions of points flying around per every time something moves, right? So now multiply that by 40, and you have a huge number, right? And what you end up with is a video game that's not playable if you do it that way, right? So there are times when you want to use composition, but you can't afford to pay the price of it, right? Which is why you need to know about the difference between aggregation and composition. All right, any questions so far on what we've talked about? Okay, part 2. So why do you need composition? So that's the real question, right? So I've just shown you how to do it. Now, why on earth do you need to do this? And it's because some classes, not all, but some, right? Some classes have what's called a class invariant, right? Which we've already talked about. So remember that an invariant is some condition, right? Something that's true or false. A class invariant is something that's true or false for an object that's always true or false, right? At least as far as the user of the object is concerned, right? So anytime the user calls a public method or calls a constructor, right? After the constructor or public method runs, as far as the user is concerned, the invariant is true. Right? So what does that mean? That means when your constructors finish running, the class invariants have to be true. Every time a public method finishes running, the class invariants have to be true. Right? So remember, our counter class has the invariant that the value of the counter is never negative. Right? So every time the constructor in the counter class runs, it has to make a counter that's not negative. right? And every time a public method runs in the counter class, it has to make sure that the value of the counter is not negative, right? Otherwise, anybody that's using the class that relies on the invariant ends up running into problems. So this example that I'm about to show you comes from the book Defective Java. It is in the library. You can actually read the article for this particular part of the book online if you want to read it. But I'm going to basically explain it to you in this lecture. You want to implement a class that represents a period of time. So for example, something that you might see in like a calendaring program, right, where you want to schedule meetings or something like that. Right? Each meeting is represented as a period of time. So it has a start time and an end time. Right? Now, for a period of time, a useful invariant for that type of object would be that the start time is always before the end time. Right? It doesn't make sense to have a period of time where the end time comes before the start time. Right? So we have a class now that has a class invariant. And now we have to decide how am I going to represent the start and end time. Right? So for this example, we're going to use this class called a date, which is Java util.date. So we'll use a date object to represent the start time. We'll use a date object to represent the end time. Right? And we have the invariant where the start time is always before the end time. Now the date class is a little bit funny. Hang on, okay, so we'll get to that in a second. So the date class is an older class. It's the original time class. It's the original class that represents a time in Java. Now because of that, it's a little bit odd to use. It's also recommended that you don't use it anymore because they've introduced new classes since then to replace it. But we're going to use it in this example anyway. Because we have a class invariant, right, and because this date object here, these two date objects are immutable, right? So in other words, you can change the date or the time that a date object represents, right? So you can move it forward in time, you can move it backward in time, and so on and so forth, right? Because this class has an invariant, right, we have to make sure that we never release a reference to the start time or the end time, right? And so in that case, we have to make sure that we use composition to protect the internal date object, right? Because if I release a reference to one of the two times, then someone can take that reference, change the time, and now suddenly you've got a period of time where the start time is after the end time. Right, which breaks the class invariant and probably breaks a lot of other classes that rely on the period class. Right, because it's a reasonable assumption to make that a period always has a start time before the end time. In composition, in your UML diagram, you represent the composition with a solid diamond. Right, so in aggregation, it's an open diamond. Right, composition, it's a solid diamond. So the way you read this diagram is a period object is a composition of two date objects. Okay, so to use the date class, you need to look at the documentation for the date class. I'm just going to show you how to use it. Now, in the composition, we have to make copies. The date class is one of those classes that doesn't have a copy constructor, right? But there is a way to copy a date object. So you use this method called GetTime, and that returns some integer value that represents the time. I think it's the number of milliseconds or the number of seconds since January 1, 1970. So again, it's a strange class, right? But you can actually get the integer value corresponding to the time, and then you can create a date object using that integer value, right? So that's how you make a copy of the date object. Date also has methods like setTime and getTime, right? That change, that you can pass in an integer value and change the time. Okay, so what does the class look like? Well, it's just a regular class, right? So public class period. Right? It's got two fields. We're going to make them private because we don't want anybody to have access to those fields directly outside the class. Right? They're called start and end, so that's the start time and that's the end time. Right? Now, we have to implement the constructor. Now remember, our constructor has to ensure that the invariant is true, right? So it has to ensure that the start time comes before the end time. So the way you might implement this the first time you implement the class, right? You create a constructor. It takes in the start time from the user, and it takes in the end time from the user, right? So we validate the start and end time, right? So how do you validate the start and end time? Well, date has a compare-to method, right? So compare-to returns a value greater than 0 if start is after end. right? Start is greater than end means start comes after end. Right? So if start dot compared to end is greater than 0, then we know that the start time is after the end time. Right? That should actually be greater than or equal to. Because the class says that the invariant is that the start time comes strictly before. So that should be greater than or equal to. So if you end up with a start time that's the same as or after the end time, we throw an exception. Right? Otherwise, now in this case, the implementation is incorrect. Right? We're going to write this start equals start. Right? So this start object is equal to that start object. Right? Is the same object as that. This end object is equal to the same object as that. Right? Now, if you write some code that uses your period class, right? So you make a start object, you make a start time, you make an end time. Right? Now, to notice that making the end time, we use start.getTime. Right? So that's the same time as the starting time. And then we add 10,000, I think that's milliseconds. So you add 10,000 milliseconds to the time. Right? So the end time really is after the start time. And then you make a new period object. Right? So if you implement the class or the constructor that way, then you can add one line of code here that makes the invariant untrue. Right? So how do you make the invariant untrue? Well, you just make one of these two. Right? You just adjust one of those two so that the start time becomes after the end time. Right? So you just look at your choices, end set time, end get time. So that doesn't change the end time, so that doesn't do anything. Right? End set time to end get time plus 10,000 means move the end time further into the future, so that doesn't do the right thing either. Right? Start set time to end get time minus 1 moves the start time 1 millisecond before the end time. So that doesn't do anything either. But end set time to start get time makes the start and end time the same, and that breaks the invariant. Right? Now, why does it break the invariant for the period class? It's because, right, when someone changes that, then this start or this end will change, right? Which we have to prevent from happening. Right? So you can actually break the class invariant not by asking the period class to do so, right? But simply modifying one of the references that you have when you called the period constructor. Right? So that's no good. Right? So how do you fix the problem? Right? So you fix the problem by making copies. Right? So step 1, copy the start time. Right? So there's the start time copy. Right? Copy the end time, and there's the end time copy. Right? So notice that we make a new date in both cases. Right? So we really do have a new date object for the start and end time. Now validate the copies. Right? If there's a problem, throw an exception. And if there isn't, we can set this start equal to the copy and this end equal to the copy. Right? And now we've insulated this particular constructor anyway from changes to that object or changes to that object. Right? If someone changes their start reference, right, the copy doesn't change. Right? If someone changes the end reference, the copy doesn't change. Okay, now what about the copy constructor? Well, this is all the same thing, right? You're just making copies everywhere you have to. Right? So if you have a copy constructor that copies another period, right, don't write this start equals other start and this end equals other end. Right? Because you're now saying that your start time and end time of this period object, they're represented using the same objects as the other period's start and end time. Right? So if you do that, what happens? Let me see if there's an example. Okay, there's not an example. Right? So what happens if someone takes the other period class, the other period object, and changes the start or end time? Then suddenly the start or end time of your new period object also changes. Right? So don't write that. Right? Write that instead. Right? Make a copy of the other object's start and end time. Right? And it's the same thing for the accessor methods. Right? If you want to tell somebody what is the starting time of this period, right, don't return this dot start. If you want to tell somebody what is the end time of this period, don't return this dot end. Right? Because if you do so, you've just returned a reference to your internal date objects. Right? Instead, make copies of your internal date objects and return those. Right? Here I've used the GetTime method. Oh yes, you have to use GetTime method. Right? So this dot start dot GetTime, right, to make a copy of the date object. Right? Now here's a mutator method. Again, it's all the same thing. Right? So if I have a mutator method that's supposed to set the start time to new start, right? Whatever you do, do not write this start equals new start. Right? Do not write that line there. So what do you have to do in this method? So this method, you have to do some validation as well, right? Because if someone wants to change the starting time of the period, you have to make sure that the starting time of the period is still strictly before the end time. Right? So again, you need to do a validation here, right? Only if the validation succeeds do you set the start time to the new start time. Right? Now in this case, there's still a mistake, right? Because you've written this start, right? So your internal date object is the same date object as that one. So that's a problem, right? If someone modifies new start, then this dot start also changes. So what do? Make the copy, right? Validate the copy, and then away you go. Okay, so you always have to make sure to be making copies when you need to. Right? So all of those examples that I showed you, those are all examples of privacy leaks, right? If you've got some class X, internally it's got some Y object, right? Then whenever you write this Y equals Y, or return this dot Y, right, you've got a privacy leak, right? You have to, in this case here, you have to make a copy of the incoming Y object. Here you have to make a copy of the other object's Y object, right? And here you have to make a copy of the incoming Y object, right? In the accessor methods, you have to return a copy of your internal Y object. Right? So what's the consequence of having a private? So what happens if you implement a composition and you accidentally release a reference, right? You accidentally have a privacy leak, right? So a privacy leak allows some other object to control the state of the object that leaked the field, right? So what does that mean? So your object state can become inconsistent, right? So for example, if you have a credit card, right, and the credit card releases a reference to its expiry date, right, then someone can change the expiry date so that, for example, it comes before the issue date. Right? So now you have a credit card that doesn't make sense, right? You can have a period class where the start time comes after the end time. Right? A privacy leak allows some other object to control the state of the object that leaked the field. Right? And that means it's impossible to guarantee class invariance, right? Which is why you need composition, right? Which is why you need a correctly implemented composition. Right? If your class has a class invariant, right, and the invariant involves some sort of mutable reference type, you have to use composition. Right? So if the period exposes a reference to one of its date objects, then the end of the period can be set to before the start of the period. Right? And you now have a period object that doesn't respect its own class invariance. And this means that composition, basically you have a broken composition. Right? Because the object no longer owns or has exclusive access to its own internal object. And that means that when the object goes away, right? So when you're done with the period object, the way it's supposed to work is that the internal date objects should also go away. Right? But if someone has a reference to one of those internal date objects, then those date objects don't go away. Right? So when an object quote unquote dies in Java, right, its parts may not die with it. And that's not the way it's supposed to work. Okay, so a while ago, we talked about how to make an immutable object, right? Or an immutable class, right? So to make an immutable class, your fields are all private, right? So rule number 4, right? You make your fields private so that nobody outside the class can access the fields directly. You make your fields final because your object's supposed to be immutable, so its state should never change, right? So in other words, you don't want to assign a value to your fields more than once. Right? You have no methods that can change the state of the object, right? So provide no mutator methods. And before I told you that we also do step 5, right? Prevent clients from obtaining a reference to any mutable fields, right? So now you understand, well, hopefully now you understand why you need step 5, right? Because if you give someone a reference to your internal field, somebody can change it, right? So if you have an immutable object, right, that's also a class invariant, right? So saying that your class is invariant saying that your class is immutable is a class invariant, right? It makes the promise that once you set the state of the object, it never changes, right? So if you implement your class in a way that uses a mutable field, right? So for example, you have an array or a list inside your class, right? You have to make sure no one gets a reference to that array or list. Okay, all right, so composition with an array. Right? So in Java, an array is a reference type. Right? All right, so if a class has a field that's an array, right, that is an array, right, then you need to consider whether you should be using aggregation or composition. Right? Now, if you have an array of primitive type, that turns out to be easier than working with an array of reference types. Right? Because if your array is an array of reference types, you now have to worry about whether or not you own the elements that are in the array. Right? Here, for the time being, I only want to be interested in whether or not I own the array. Right? I don't want to worry about whether or not I own the stuff in the array. Right? That's probably next lecture. All right, so I want to implement a simple combination lock class. Right? So this is just imagine you have a lock where you it's got some dials or numbers on it, right? So you can change the numbers to a certain sequence, and then the lock will either, if you enter in the correct combination, the lock unlocks. Right, so I'm going to implement one of those, like those cheap bicycle locks. It's got these dials with 10 numbers on it, right? And you change each dial. So each number is between 0 and 9, right? And you have 3 or more digits. Right? Your lock is always locked or unlocked, right? So it's not a terribly difficult class to implement, but you have to pay attention to the details when you're implementing the methods that involve the array that I'm going to use to store the digits. Right? So how am I going to store the digits? Well, it's 3 or more, right? So it's actually having at least 3, right? So it looks like it's a possibly variable number of digits. Which means I can't just use 3 fields, right? I can't use number 1, number 2, number 3, right? Because if I have a 4-digit lock, I can't add another field. So I'm going to use an array in this case. You could use a list, but it's easier to talk about arrays for now. The lock is always locked or unlocked, so I need some field to store the state of the lock, right? So that's going to be a Boolean value, right? True is locked, false is unlocked. Oh, and it looks like I'm going to be able to, I don't know why I'm comparing combination locks, but that method, it's there for now. Right? So how do I represent the combination? It's just a plain old array of int. Right? Notice it's private. It's private because I don't want anybody to look inside the array from outside the class. Right? Otherwise, they can look at the combination and unlock the lock. I have a field called isLocked. That's true if the lock is locked. It's false if the lock is unlocked. Right? Notice here, right? There is no actual array yet. Right? There's a field that can point to an array, but there's no array. Right? So inside every one of your constructors, you've got to make that array. So here's the no argument constructor. So the no argument constructor initializes the lock so that it is locked, and it has the combination 999. Right? So what do you have to do? Well, I have to make that array. Right? So this combination equals new int 3. I store 9 in the array 3 times. Right? And I set is locked to true. Right? So that's pretty easy. You'd have to do this anyway, right? Whether you're implementing aggregation or composition. Now, any constructor that receives the combination from the caller has to make a new copy of the combination and then validate the copy. Right? So what does that mean? Right? So in other words, if someone passes in an array containing the combination, right? What you must not write is you must not write this combination equals combination. Right? Because when you write that, you're saying your array, right, the array this combination is the same array as the incoming array. Right? Points to the same array, which you don't want to do. Right? What you want to do is you want to make a new array, and you want to copy the numbers in the incoming array into your new array. Right? So if you ever have to make a copy of an array, don't do it yourself. Right? Use array's copy of. Right? That does all the copying for you. So it actually makes the new array for you, copies the elements from the old array into the new array. Or sorry, copies the elements from the copied array into the new array. Right? So the way you use it is array's copy of. That's the array that you want to copy. That's how many elements you want to copy out of the copied array. Right? So if you want to copy everything in the incoming array, then you use the array name.length. Right? And that copies all the elements. Right? And gives you a new array. Right? And now I can do whatever validation I need to do with that incoming combination. Right? So for example, I can validate whether or not that combination has at least 3 digits. Right? Because if it doesn't, then that breaks one of my invariants. Right? One of the class invariants is that the lock always has 3 digits or more. Right? You should also check whether or not each of the numbers in that array are between 0 and 9. But it looks like I've neglected to do that, right? But you should do that. Right? Once you've made the copy, validated the copy, you can go ahead and set this combination to be equal to your copy, right? And then lock the lock. If you have a copy constructor, you've got to make a copy of the other lock's array, right? Now, this is where constructor chaining becomes useful, right? So instead of repeating all of this code, right, to implement the copy constructor, I can just chain to the other constructor that I've already implemented, right? So on the first line of this constructor, I can call the other constructor, passing in the array that I want to copy. Right? So that's right there is a good example of using constructor chaining to avoid repeating yourself. Right? And then go ahead and set this locked equal to other is locked. Yep.
And here there's no problems because the other constructor already makes a copy.
The other constructor already. Yes, that's right. So when you run the other constructor, the very first thing it does is make a copy. Right. Now there is a small problem though, right? So if you're copying another lock, right, the only way that other lock could have been made is if someone called the constructor and successfully made the other lock. Right? So what does that mean? It means that that other lock has a valid combination, right? Assuming the rest of your class is implemented correctly. Right? So in other words, you don't have to validate that other lock's combination. Right? But when you use constructor chaining, right, we make the copy, which we have to do, but then we do the validation. Right? So you're unnecessarily validating the incoming object. Right? Which in this case isn't a big deal because the validation's easy. Right? But if the validation's complicated, then it becomes a problem. Right? If it's complicated or time-consuming, then you may want to consider rewriting your constructors in a way. So you want to create a private constructor that does the same thing as this constructor, but doesn't do the validation. Right, to avoid the cost of copying. To avoid the cost of validation. Right? In this course, we're not worried about that. Right? Just go ahead and chain to the other constructor. Now, I've talked a lot about copying stuff, right? But you have to keep in mind that not every method has to make a copy. Right? The only time you have to make a copy is when there's a danger of releasing a reference to the internal object. Right? So in this case, the only time I have to make a copy of the array is when I might release a reference to that array. Right? So for example, if I want to unlock the lock, right? So someone gives me a combination to unlock the lock with. Right? What do I want to do? I want to check if the incoming combination is the same as the internal combination. Right? But I don't have to make a copy of the incoming combination. Right? Because I'm not going to do anything with that. I'm not going to modify my internal combination. Right? So I'm not making any changes to my combination. I'm not releasing a reference to the combination. I don't have to make a copy. Right? One of the problems when you do this sort of lecture for students who are new to Java is they just copy everything all the time. Right? But you want to avoid doing that because copying stuff in Java is expensive. Right? Copying stuff in any language is expensive. Right? You end up using memory to make the copy. It takes time to make the copy. You want to avoid doing that if you don't have to. Right? So to check if an incoming combination, to check if that combination can be used to unlock the lock, right? Don't make a copy, right? Just check, is that array equal to your internal array, right? So to check if two arrays are equal, use array.equals, right? And that will actually go element by element comparison of the two arrays. Right? So in other words, it'll check if this combination element 0 is the same as combination element 0, and it'll check if this combination element 1 is the same as combination element 1, and so on and so forth. Right? If the arrays have different lengths, this will automatically return false. Right? So two arrays are equal if they have the exact same length and they have the exact same elements. Right? So there's no copy here. Right? And there's no point to making the copy, so don't make the copy. Right? Your code's not wrong if you make the copy of that thing there. Right? It's just doing a lot of unnecessary work. Right? So if the arrays are equal, I'm going to unlock the lock. How do you unlock the lock? You just set this is locked to false. Right? Otherwise, it leaves the state of the lock unchanged. Oh, that's it. I'm going to stop there, I think, today. The next lecture talks about creating a class where the field is a list or something like that. Right? Now when you have a list, the only way you can make a list is to have the elements of the list are all references, right? Because you can't make a list of primitive type in Java. That complicates things because now you have to decide, do you own the elements in the list as well, right? And so we'll talk about that in, I guess, 2 days, so on Wednesday, right? If you haven't noticed, there is an assignment out. In that assignment, you actually need to make a list or an array of some type, right? So you actually need to be aware of the lecture today in order to do the assignment correctly. Okay? Thank you, everybody.